10.1 Sequences, Series, and Sigma Notation. First part we have to do is we have to define what a sequence is. And so in our textbook it says that a sequence is an ordered pair or an ordered list of numbers. Each number in that sequence is known as a term. There are types of sequences. An infinite one or a finite one would mean that you know exactly how many are in the series or sequence. So this would be like 1, 3, 5, 7, 9, and 11, and the sequence ends. Infinite is where you'll see similar sequence. However, at the end it has these 3 dots, and these 3 dots means it's going on forever. Big thing about understanding sequences is each term of a sequence is a function of its position. So if you look right here, f of 1, that is the a sub 1, that's the first term. This would be the second term, this would be the third term, and this would be the nth number terms. Now I made my a little bit larger so I could get a little bit more room, but the first one says find the next 4 terms in the sequence. Well, first I need to distinguish what's happening to the sequence. Is it going up by a certain number, or is it going down by a certain number? And it looks like right here 5 plus 2 would give me 7, and 7 plus 5 would give me 12, and 12 plus 5 would give me 17. So it looks like I'm adding 5 to each of the previous terms. So to figure out the next 4, I would just have to do a sub, this is 1, 2, 3, 4, this is the 4th term. I'll write that A a little bit better. So the 5th term would look like this. 17 plus 5 is 22. A to the A sub 6 would be 22 plus 5, which is 27. A to the 7th, or sub 7, would be 27 plus 5, which is 32. And then we have A sub 8, which is the 8th term, which would be the last of the 4, which would be 32 plus 5, which is 37. So the next 4 would be 22, 27, 32, and 37. Example number 2. Find the next 4 terms of the sequence. Okay, now this one's a little bit different because I'm noticing that it's going up by varying numbers. So this is going up by 3, but this one's going up by 5, and this one's going up by 7. So it looks like you're going up by odd numbers as you go through. So if this is the 4th term, so then the next one would be A sub 5. And so that is going to give me 17 plus 9, which is 26. And then A sub 6 is going to give me 26 plus 11, because that's the next odd number, which is 37. And then A sub 7 is going to give me 37 plus 13, which is going to give me 50. And then A sub 8 is going to give me 50 plus 15, which is 65. So then my numbers are 26, 37, 50, and 65. Then, for example number 3, we have to find the first 4 terms in the sequence given by A sub n is equal to 2n times negative 1 to the nth power. And basically wherever this n is, so if it's the first term, you're going to put 1 in. If it's the second term, you're going to put 2 in. If it's third, you're going to put 3, and so forth. So we're going to start with the first term, so A to the first, or A sub 1, so it's going to be 1 times that, times negative 1 to the first power, which gives us negative 2. Then we're going to put 2 in, so everywhere we see n, we're going to put 2. And that's going to give me 4. And then A to the third, it's going to give me 2 times 3 times negative 1 to the third, which is going to give me negative 6. and a to the fourth is going to give me 2 times 4 times negative 1 to the fourth equals 8. And so this is going to be negative 2, 4, negative 6, and 8. Okay, explicit sequences gives the sequence as a function in the number of terms, n, whereas a recursive, so this is a definition, the recursively defined sequence gives the first term of a function, and then you have to find the next terms using that first term. Big thing that you need to remember is n minus 1 is the previous term. So when I look at this example, number 4, it says that find the fifth term of the recursively defined sequence. And I noticed in the textbook that there is a typo, which unfortunately I put it on this paper, but a sub 1 is actually equal to 2. And so right here we're going to look at our function and we're going to plug in this information to find all the values. So to find a sub 2, which would be in this group, it's okay, would be 2 plus 2 times 2 minus 1. So this is 4 minus 1 plus 2. 6 plus or minus 1 is going to give us 5. And then a to the a sub 3 is going to be, now I take the previous term, which is a sub 2, plus 2 times 3 minus 1. So 5 plus 6 minus 1 would give me 10. And then a to sub 4 would be 10, because that's the previous term, plus 2 times 4 minus 1. So 18 minus 1 would give me 17. And a to the fifth would give me 17 plus 2 times 5 minus 1. So we've got 27 minus 1 is 26. Okay, series. A series is indicated by a sum of the sequences. So you're actually going to add your sequences. Like sequences, series can be infinite or finite. I have a hard time saying those. Finite series is with a fixed number. You know exactly where it's going to end. You know how many terms there are in it. And then an infinite one would be where it goes on continuously and indefinitely. And this is where we're going to kind of later on or in class we'll talk more about convergent or divergent series. And you probably have to look at the pre-AP video if you want to go into that. That's definitely going to be a calculus issue if you are thinking about doing calculus. Okay, so example number 5. It says find the fourth partial sum of a sub n is equal to negative 2n plus 3. So the first thing is we have to find all the terms, the 4 terms. So a1 is going to be negative 2 times to the first power plus 3, which is 1. And then a sub 2 is going to be negative 2 squared plus 3. So 4 plus 3 is 7. A to the sub 3 would be negative 2 cubed plus 3. So that's negative 8 plus 3 would give you negative 5. And then a 4 would be negative 2, 4 plus 3. So positive 16 plus 3 would give you 19. So S4 would be 1 plus 7 plus negative 5 plus 19, which is going to give me 22. Going to do the same thing for this next set. So A1 is going to be equal to 4 over 10 to the first power. A sub 2 is going to be 4 over 100 because 10 squared would be 100. A sub 3 is going to be 4 over 1,000. And when I sum these, 4, 10 plus 4 over 100 plus 4 over 1,000. Now if you wrote these in decimals, this would be this, and it'd be pretty easy to see what the answer is. So this would be equal to 0.444, or 444 over 1,000. Okay, summation or sigma notation, shorthand used to write the sum of, is most often used, especially when you're using the explicit formula. And we're going to use our calculator to do these. I'm sorry, since I zoomed out, it kind of zoomed it all forward here, or half of it off. But it says, for any sequence A1, A sub 2, A sub 3, A sub 4, the sum of the first k terms is denoted with this notation, okay, right here. And this just says this is where you're starting, this is how many terms you want to add, and this is the equation that you're going to use. So if we look at the first example that we have right here, and I'm sorry that it scrunched them up like this, we're going to put in our calculator, and we're going to go math. We're going to scroll all the way to the bottom where it says summation, and we're going to punch that. I guess you don't need to punch your calculator. Then you're going to put, calculator can't use n, so you're going to use x. You're going to put x here, and you're going to put x here, and when you hit enter with that, you're going to get 45. What it's actually doing is the calculator is putting 1 in. So 4 times 1 minus 3 would give you 1. Then you're putting 2 in. 4 times 2 is 8 minus 3 would give me 5. Then you're putting 3 in. 4 times 3 is 12 minus 3 would give you 9. And you keep adding those all together. The calculator actually goes and does that for us. So that's what the calculator is writing out. I might ask you to write this out, but if it's calculator form and I don't ask you, you can go straight to the answer. Same with this one. This is x. You're going to go to 3, or you start at 3, go to 7. You're going to put in all those numbers into your calculator. This is an equation, and you can put parentheses around that. In fact, I would. And that should give you 135 over 2.